In the previous video, we looked into the purpose of SV agents as well as we explained how to use your SV Designer to manage multiple SV servers. In this video, we'll look into how to create a virtualization project on one of these servers that are available. But before we start, let me open this hands-on instructions file and tell you a couple of words about the business motivation of this whole hands-on series. In this training, imagine that you are a member of a team responsible for developing a web application for trading various assets, and you heavily rely on a dependency called Portfolio Suggestion Service. And this service is responsible for providing you hints of what your customers should buy, what assets they should buy based on certain input parameters. And you will have to deal with a lot of different issues that are usual when you try to integrate your application with various dependencies. So initially, the team behind this portfolio suggestion service on which you heavily rely was unable to deliver anything. And when they finally delivered, after months, their service was buggy, provided inconsistent output, and performed badly, and also it contained sensitive data, and some important features were undocumented or missing with no clear outlook to fix. So these are things that really happen in practice. They were also unable to generate test data of a realistic size because you need to test your UI that you develop to find out whether it can deal with a lot of data, not just basic tiny sample messages. And in the end, they even started to charge your team for overusing their test environment since they had to outsource some stuff from a third party. Luckily, when you use Micro Focus Service Virtualization, you can mitigate various negative effects of these issues caused by other people and other teams. In this training, we will replace this portfolio suggestion service with a virtual service simulating its behavior. This is what we call virtualization. So how this portfolio suggestion service works? Well, this is its request. As you can see, you provide several input parameters based on which the service returns the suggested assets. These parameters are the purpose of your investment, the risk level. The higher the risk level is, the more risky is the investment. Also, you provide the intended investment amount and details about the customer, because banks usually need to run some checks, which is usually called KYC, Know Your Customer. So this is the response. The service responded with information about the customer along with some internal identification if the customer was found in the system. But most important, it retrieved a list of assets, the suggested assets to buy. The assets are identified by this ISIN identifier. This is the number of units to buy, the current price, and risk level. For individual assets, we also have this market quote time, informing us how recent this market price is. The service retrieves an array of assets, and here you can see a detail of one of these array items. Then we have some global information like the total value in USD, which is sum of values of these assets, and some transaction ID and hash. And that's all. The interface is pretty simple. This is the request. This is the response. Now we will start virtualizing this behavior in steps. We will start with a not very sophisticated basic simulation, and we'll add more and more features, making the simulation more and more realistic, more and more sophisticated. And throughout the hands-on exercises, we will showcase various SV features that can help you make your simulation better. In the first exercise, we will have to create a virtual service from scratch. Reason being that the team responsible for developing the portfolio suggestion service was unable to deliver anything, So we will have to use documentation, and using some basic sample messages, we will establish a virtual service that will simulate basic calls to the non-existent real service. And by the real service, we mean the portfolio suggestion service when in the future it will be made available. But currently it doesn't exist, so we have to deal with it. In our case, that means we'll have to create a virtual service from scratch. Let's start by installing the SE Designer as shown in this document that you can download using the link mentioned in the description of this video. It's practically just clicking next, next, next. The link to this document is also mentioned here in the first step of this hands-on 0. The next step describes creation of our first service virtualization project on the embedded server. I've already installed the SE Designer, the free version, on my machine, so I can create a new empty project by clicking File, New Virtualization Project. Let's use the same name suggested here. When creating virtualization projects and virtual services, it's always good to choose meaningful names, and if you have many projects or many services, it's very convenient to use some naming convention. Besides the project name and the folder where all the project files will be stored, we can also immediately select on which server will deploy our virtual services. In the previous video, I added one other server to my embedded server. When working with the SE Designer, this embedded server is always available because it runs locally in my SE Designer. So in your case, likely you will have this only option, and that's a good option when you want to start creating a virtual service, developing it step by step. After you reach a certain level of maturity, you can, in a very simple way, move your virtual service to some standalone external SE server, and you can make your service or services available for other people to use. So as I said, we'll start with the embedded server. We'll press Save, and as you can see, a new empty virtualization project was created. And that's it. Now we can start with creating our first virtual service as suggested in this third step. We'll create an empty virtual service based on no service description. I'll comment on this a little bit later. What is important is to know in advance what will be the protocol the service will use. You can't infer this, somebody needs to tell you. The name of our virtual service will be Portfolio Suggestion Service, so I'll just copy this to clipboard. It will be deployed on this HTTPS gateway agent. We don't have the real service endpoint yet. We'll perhaps specify it in the future. And what is the most important parameter is the URI path. Again, I'll explain a bit later. So let's return to our SE Designer and let's create a new virtual service. You can do it by clicking Add Virtual Service, or you can use this special icon. When you click it, this wizard will pop up. The first step here is to decide whether your virtual service will be based on some existing service description file. That can be a WSDL file or an OpenAPI file or COBOL copybook. Sometimes you have no other option than to base service description on some service description file, for example, for these mainframe protocols. But in our case, since our service will use the REST protocol, SV is capable of learning the messages on the fly. You don't need to import any service description file describing the service, its structures and operations. We will simply learn everything on the fly. So for protocols like REST or SOAP, basically protocols that use JSON or XML, you have usually both the options. Use this one if you don't have any service description file available, which is quite often, and also if you are afraid that the provided service description file, like a WSDL file, can be out of date. And that happens a lot. On the other hand, if you integrate with some stable public interface like a payment gateway, then you can be sure that the OpenAPI file or WSDL file will be up to date and fully functional. In that case, I would suggest to go with this service description option and just browse for that service description file and specify it, because you don't have to be afraid. It will surely be up to date and it will provide you a better user experience inside the data model editor where you edit the virtual service behavior. But we don't have anything like this, so I will simply choose that I don't have any service description, and as we will learn all the message structures on the fly. I usually prefer this option because the user experience may be slightly worse, but this option is always safer because as we will use the real messages that you import or learn from the real service, so your structures will always be up to date. So I'll press next. Now we need to select the protocol our virtual service will use. I'll use this text field to search for the REST protocol. You can also filter protocols by message format or by the method of transport. So if I just cancel this and go over the protocols, you can see that very often protocols have names in this kind of format: XML over file system, meaning type of message or format of message over certain way of transport. For XML, we have XML over Microsoft MQ, or over TIBCO, or over WebSphere MQ, or over file system. Similarly, for file system, you can create services that will relay binary data over file system, CSV data over file system, and so on. The REST protocol is a little bit special, since the REST protocol uses many types of messages, JSON or XML or even images. So let's click Next, and on the next screen we'll select the agent on which we'll deploy our service. And according to these instructions, it should be the HTTPS gateway agent. So that's what I selected, and the most important parameter is this suggest portfolio URI path. So let me uncheck this use real service checkbox, since we don't know yet what the real service URL will be, and the path will be this URI path. And as you can see, our virtual service endpoint, which is where my virtual service will listen, is given by the machine name and this port, and then what follows is the URI path. This is our virtual service endpoint. So when we create this virtual service, this is the endpoint that will send our requests to. And this port, by the way, that's defined on the agent level. When I click Manage Agents, you will see that the HTTPS gateway agent listens on this 7205 port. So this is my SV server, that's the embedded server running locally here on my machine inside this SV designer. And this is the second part of the virtual endpoint path, which is the URI path that we specified here. So on one agent, you can have multiple virtual services. Now I click Next. Yeah, and we should change the virtual service name here, just to have some meaningful name. We'll review the parameters, save it, and press Virtualize. Here, this dialog informs us that this virtual service will only be able to run in simulation, since for learning or forwarding or standby mode, we would need a real service. And we don't have any real service yet because it's not yet available. The team failed to deliver the portfolio suggestion service, and we may specify it in the future. So I'll just press OK. And this is, by the way, not very usual situation. In usual situation, you have a real service. It's already existing and you can use it. And that's better, that's simpler, but it's not our case. In this training, we'll start from scratch, and later, when the real service is available, we'll specify the real service by clicking Edit here and specifying the real service. So currently, we have just the virtual service URL, and we can test it as suggested in the next step. Make sure you can successfully call the service from your REST client using the post method to get the 200 OK status code. You'll likely need to disable SSL certificate validation first. The response message body will be empty since there is nothing inside your data model yet. Let me comment on this step. So firstly, you'll have to download and install some REST client. Different people have their favorite REST client. If you don't have one, just search for REST API client on the internet, download and install one. Our virtual service uses HTTPS gateway agent that uses the self-signed certificate, if you didn't specify otherwise during the installation of SV Designer. So that's the reason why you will likely need to disable SSL certificate validation first from whatever tool you will use. I will use this very simple tool that I created for this series of hands-on exercises. It has just 4 fields: the URL of the API of our virtual service, the accept header value, the content type header value, and the request. In the REST client tool of your choice, you will have to fill in similar fields. So let's do it. So this is our REST API virtual service endpoint. And throughout our exercises, we will always use text XML content type. So after clicking send, I receive the empty message as suggested here, because there's simply nothing specified inside our virtual service data model. But at least we don't get any error. When you look into the SV Designer, you can see 2 messages along with this warning that was generated. This warning says that the root test element was not found in the service description schema, and we need to probably learn the structure. This is because the virtual service didn't recognize this payload. But virtual services always try to respond with at least something. What is important to understand is we always send requests to this virtual endpoint. This is the endpoint on which our virtual service is listening, ready to handle requests and generate responses. If you want to introduce a virtual service into your own environment, you will likely have to go to some config file and replace there the original real service URL with this new virtual service URL. But you will have to do it just once, because here, on the virtual service level, you can always decide whether the virtual service will provide the responses, simulate them, or whether it will forward the requests to the real service, and whether the real service will provide the responses. This is what we call the standby mode, and currently it's not possible with this service since we haven't specified the real service URL. Later, we can specify it here. You have already seen this screen once in the service virtualization wizard. You can change service parameters, so changing the URL in your config file will happen only once, and then on the virtual service level you can decide whether you communicate with the real service over this virtual endpoint or with the simulation of the same. In simulation, the virtual service generates the responses, so the real service is no longer needed. If it's down, you don't care. If it's malfunctioning, you don't care. During user acceptance testing or integration testing, you simply press stop and the virtual service will start forwarding messages to the real service.